Hello and good day. We are from Group 3. We present about our acoustic and lighting project. First of all, I will introduce myself. My name is No Atira Ilyani binti Rani. For the introduction, acoustic is an element of physics that investigates the characteristic action of sound. It comprises knowledge regarding the sound of wave propagation, absorption, reflection, and diffusion. For the lighting, the scientific, artistic, and practical utilization of light to improve the appearance of areas, establish a particular atmosphere, and serve practical purposes.
Okay, now we go to the methodology, which is consists of three sector, which is the first one is reverberation time, second one the noise background, and the third light analysis. These are the equipment that used in the noise background and the reverberation time, which is the first one is the omnidirectional sound source, the wireless audio transmitter, extension wire that measure power amplifier with noise regenerator, digital sound level meter, sound level calibrator type 4231. For the background noise, is for the all internal noise sources such as mechanical ventilation were switched on. The sound level meter was positioned at the desired location for measuring the background noise level was calibrated. The background noise level was recorded for a specific duration of time, typically for 1 minute or more. Step 3 was repeated at the multiple location in the room to obtain a complete set of data. The data was analyzed to determine the average background noise level for the room using the appropriate formula. This is for the procedure for the reverberation time. The location where the reverberation time and the background noise level were to be measured was identified. The sound level meter was set up according to the manufacturer instruction. The sound level meter was positioned at the desired location at height of around 1.5 meter from the floor for measuring reverberation time and the calibrated. The microphone of the sound level meter was set at omnidirectional pattern to capture sound equally from all direction. The sound level meter was activated and set to the measure sound level over time. An impulse signal was generated using a signal transmitter and input. The response of the room was recording using the sound level meter. The measurement was started by introducing the input an impulse sound signal into the room using the omnidirectional sound sources. And the time between the initial impulse, the first reflection and the first decay, and the step 6 to 10 were repeated at different location and complete data. The data was analyzed using the appropriate formula. Okay, this is the layout for the reverberation time. For the light analysis, the grid line were made establish a systematic layout for the measurement point. All artificial light were switched on. The switch of the measurement device was pushed to turn it on. The desired measuring range was selected. Lux reading were recorded by holding the digital lux meter at a height approximately 1 meter from the floor. The data display on the device LCD screen was recorded. The step were repeated until the data was complete. And these are the equipment for the light analysis, which is the digital lux meter and the type measurement. And lastly, this is the layout for the light analysis measurement.
So in this part, I'll be explaining about the background noise analysis. So for all of the data obtained from the measurement, the analysis was done by calculating the average using the sound pressure level formula. Table below is the summarization of the average background noise for all the frequency from the sound level meter. After we get the average, it was used to create a sound pressure level against frequency graph as shown at the right hand side of the slide. The combined average from all the frequency was compared to the recommended value, which below 40 dB. From the table, the total average background noise of tutorial room 1, which 36.04 dB, is below the recommended value and fulfill the standard for a lecture room.
Okay, I will present the analysis of reverberation time for our class tutorial room 1. So this is the raw data from the sound level meter that we got, and we convert it into the Excel. So we use to 4 position and we get the average for each frequency. After that, uh, from the average we get the average from the all frequency to get into one value. We also point out the average into the graph reverberation time tutorial room 1. So from the low frequency is high and it decrease into the high frequency. So the recommended value that state from Park and Han is below 1 second for lecture room, uh, not more than 50 people. So the result is 1.37 second is more than 1 second. So the reverberation time for tutorial room 1 is not good.
Move to the light analysis. The 12 zones have been divided to determine the illuminance of each zone. The average illumination in each zone is presented in table. In accordance with the findings of the investigation, the illumination level designated by the standard is not exceeded by any of the zone. In contrast, the average illuminance values in Zone A, Zone D, and Zone G are in close proximity to the designated standard level values of 204, 252, and 235. Permissible levels of illumination, as specified in MS 1525-2014, range from 300 to 500 lux for the classroom. However, it is important to highlight that the illumination level in the entire tutorial room is insufficient to meet the criteria established by the guidelines. As you can see in the slide, the yellow color found on the contour indicates that the zone D has a high level of illuminance among others. This is because of the is near to the room door and window. Then let's calculate the lighting improvements. For the lighting luminance factor for painted surface for ceiling, white cream is 70. For the walls, light stone is 50. And after calculate the room index by using formula, the result is 1.0. So the luminance factor is 0.53. Then we use the formula number of fitting and we got 12 unit lamps that are necessary for the room to have better lighting.
Hi, Assalamualaikum. My name is Ismail bin Amran, number 3CF200162. So today I'm going to present acoustic improvement and conclusion for this project. This table will serve a recommendation value to underscore any deviation from the specified benchmark and provide a clear overview of the acoustic characteristic under consideration for this project. Okay, so for the classroom BT1, which is our place, has a background noise level of 36.04 dB, below the recommended 40 dB, 3 holes, which is good, but its reverberation time is 1.37 second, exceeded the ideal is 1.0 second. While background noise is acceptable, the extended reverberation time suggests acoustic challenge. To enhance the learning environment, address the high reverberation time in BT1, in class BT1. Next is our conclusion. So what can we conclude here is for tutorial room 1 at FCAP, UTSM does not meet ANSI standard for reverberation time. And then speech intelligibility is compromised, necessitating improvement. And then crucial measure includes using sound absorbing materials and optimizing room layout. Next one is consultation with acoustic specialist is recommended for telesolution, and the room experience lighting issues with illuminance level below norms. Next, repairing lamps and optimizing natural light through layout adjustment are key. And the last one is improvement enhance the learning atmosphere and contribute to energy efficiency. That's all from us. Thank you.